The polyacrylamide gels are stored in the refrigerator. They come from Biorad. Cabinet T3 holds all the supplies needed to run a gel. We will need this power supply here. We will need the gel box here. We will need some buffer, which is also stored in this cabinet. Later on we'll need some stain. Initially I need to set up this inner compartment of the gel box. You could run two gels, one on each side, or you can run one gel with the other side occupied by this buffer dam. This looks like it might be disposable, but it's a very important piece and should never be thrown away. Buffer dam will go on one side. These side arms snap up and hold things securely in place. There's a gasket here that makes a seal. This gel is expired, so this will be good for our practice. I open the plastic container. Inside I have this is called a gel cassette. There are instructions. Remove tape at the bottom. So that's here at the bottom. Green tape. Removed. This is electrophoresis, and we need to run electrical current through the gel. The tape would act as an insulator, that's why it must be removed prior to running. There is a comb here. This green section is removable. The comb must face toward the inside of the gel compartment. So I'm going to push this gel cassette in here. So these little ears at the bottom are holding the base of the gel. Buffer dam is on the other side. Hold it together with my hands. Flip up the sides like so. We use a running buffer as the electrolyte for the gel. It holds the pH at the right value and it has enough conductivity to run the gel in a short amount of time. We buy this from Biorad. This is a 10x concentrate. Take 100 milliliters of this, dilute it with 900 mils of water, and this is what the running buffer is. My next step here is not a standard step, but I will test the seals on this compartment. I should be able to pour in buffer, and it should remain in the chamber without leaking. I don't see any puddles forming on the bottom, which is an encouraging sign. So it looks like I have adequately sealed this compartment. Normally I would fill this at a later stage. The gel box has these two ears, and it has a red and black color coding. The inner gel box compartment also has red and black. Must be aligned, and it is appropriate to use the slots where the ears are. The power comes through this lid. You can see there's red and black, which must align with the red and black of the inner compartment. The ears will poke through the lid. Now I'm ready to add buffer to the entire gel box. There's a line here that says for 2 gels. 1 or 2 is what it should say. So I can fill up to the line with buffer. And the inner compartment also gets filled with buffer. The inner compartment will have a higher water level than the outer. And this is why it's important for there to be no leaks. If there's a leak, then the inner compartment water level will drop, and then the top of the gel will run dry, which will stop the electrophoresis. I'm now ready to remove the comb There's a little notch here that allows me to grip the green comb. I want to pull straight up, slowly, gently, straight up. You can now see there are these numbers, 1, 2, 3, 4, 5. My water level is too low. I need to have the water level above the inner glass plate. You can see there is a line above the numbers. It's not a black line, it's more of a light line. That is the inner glass plate. The wells are now flooded with the buffer, and that's what I desire. This is the overall appearance of the gel box when it's properly loaded with buffer. To load the gel, I use special tips for the micro pipettes. Here you can see that it's got a very slender end, and this will help me deliver my sample exactly where I want it to go in the gel. I'm going to try to load 15 microliters into lane number 3. This is my 15 microliters of loading dye. It is denser than water, so it should sink to the bottom of the well. The narrow pipette tip will fit between the 2 plates of glass. So I'm inserting into slot number 3, and I'm slowly ejecting. If I push too fast, I may disturb the purple dye. That looks very good. You can see the purple dye settling toward the bottom of the well. A common error among beginners is you miss the well. And it looks like I'm in well number 4, but I am not. And the dye is simply plummeting to the bottom of my electrophoresis chamber. So if you see this happening, you don't continue as I did. You stop immediately and you realign your pipette tip. There's 2 plates of glass here with about 1 millimeter separating the 2, and your pipette tip needs to be in that 1 millimeter gap. I'm pushing up against the front wall. I think I'm in. Let me try to move my pipette tip. I can tell from the lack of mobility that I am in slot number 4. Slowly eject. That's a good load. Here you can see we have 10 wells. There are different kinds of gels with different numbers of wells and different sizes of wells. These are good for a beginner because they can hold up to 50 microliters, and 10 should be sufficient for us. In this case I've just loaded dye, but I'll pretend that this is a meaningful sample. I attach the lid to the box, the ears pop through. Red is to the red and black is to the black. I attach the other end to my power supply. Again, red is to red and black is to black. On the power supply, this comes out at a slight angle, so don't try to force it in straight. Instead, let it be at an angle. Turn on the power supply on the side. That's a master power switch. I can choose whether to run at constant voltage or constant current. A for amps, V for volts. I will want voltage. I can press this up button until I get to the desired voltage. So we'll run this gel at about 200 volts. To start it, I click on this button, running man, standing man. So run will make it go. I'm about to press start on the power supply. Look for a line of bubbles to appear. That's a sign that electrophoresis has begun. There are bubbles in the back now, a curtain of bubbles rising up. So the bubbles come from the electrolysis of water. That's some hydrogen gas being produced there. We're about 20 minutes into the run. You see the dye has compressed into a narrow line. That happens as the material goes from the stacking gel, which is a low percentage, fairly porous gel, into the resolving gel, which is much stiffer and compresses the material into a line. So this is looking good. We will run this until the dye reaches the bottom of the gel. So now the dye is very near the bottom of the gel. It still has probably another 10 minutes to go. And the lines are very nice and sharp. I have here about 300 milliliters of water, tap water. I'm going to microwave that until it's close to boiling. So now I have preheated the water in the microwave. It doesn't have to be a rolling boil. Simmering is okay. I have a lid to help keep the heat in, and the hot plate is set at a high enough temperature to keep it warm. We'll use a flotation device made out of styrofoam, and the tubes get put in the flotation device so that the bottom of the tubes will be immersed in water, and that's all we care about. So it should look something like that, where we can see the bottoms of the tubes, which will be purple from the dye, immersed in the water for about 5 minutes. After heating appropriately, forceps will help remove the flotation device with your samples. They can be stored in the refrigerator for about a week, and they'll still remain ready for protein electrophoresis. This is the Lemley sample buffer that is used to prepare protein samples for SDS, polyacrylamide gel electrophoresis. You can see it's nice and purple colored. Typically you use 50% of this and 50% of your protein sample. So this has within it SDS, which will help denature the protein, and it has some glycerol to make it denser than water so it will sink into the wells. Refrigerator box J has dithiothiotol. These instructions give you the proper ratio. You can use a slightly larger or smaller mass as long as you correspondingly increase or decrease the volume of water. Before I can open this bottle, it needs to be warmed up to room temperature. If you take a cold bottle and you open it, moisture from the atmosphere will condense inside the bottle, and that is not what we desire. So warm it up, then open it, weigh it out, close it up, back in the bag, back in the fridge,